Hello, and welcome to the next lesson regarding inequalities. This one has to do with actually solving inequalities, in particular, solving linear inequalities. So let's get right to our first example, okay? We begin with the inequality x plus 5 is greater than 9. So this is our example 1. And we're going to solve this for x just like we would if this were an equal sign, which means we want to get x by itself. So in order to get x by itself in this inequality, we're going to subtract 5 from both sides. So I'll subtract 5 here, subtract 5 here. And what does that leave me with? Leaves me with x is greater than 9 minus 5 is 4. This leaves me with this inequality, x is greater than 4. Now, what does this look like on a graph? Well, let's draw our number line. And let's start with -1, 0, 1, 2, 3, and 4. Actually, you know what? That's not a good number line. That is not a good number line, y'all. Let's start again. Because I need a number line that represents all of the values that are greater than 4. So let's try this number line. How about one that starts at 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. X greater than 4. Where's 4 on my number line? Here it is. Since it's just greater than, then at the point x equals to 4, I'm going to put my parenthesis. And now I want to draw my arrow to the right to represent all the values of x that are greater than 4. So I draw my arrow to the right. And there you go. Now, in interval notation, I can write this as 4, comma, we're going to infinity. And since I have parenthesis here on my number line, I'm going to have parenthesis here. Excuse me, and remember we have parenthesis because of my symbol was greater than. And then for infinity, we're also going to have parenthesis. So for the inequality, x plus 5 is greater than 9. We solved it. We got x is greater than 4. We graphed it on a number line. And then in interval notation, this is what we have. Okay, that's problem 1. Let's move to problem number 2. Again, if you have any questions or if something did not make sense, rewind this back a little bit, watch it again, and I hope it will make sense once you watch it once, twice, 3 times, how many ever times you need it. Just want to make sure you understand. Okay, problem 2 coming up. For problem number 2, we're going to have the inequality n minus 1/2 is less than or equal to 5/8. Yes, you can use fractions with inequalities. So example 2, if n minus 1/2 less than or equal to 5/8. And we're going to solve this thing for n, meaning I need to have n by itself on the left-hand side and all the other numbers to the right-hand side. Since this is minus 1/2, to get n by itself, I want to add 1/2. And when I do that, I end up with n is less than or equal to, remember you all, how we added fractions with different denominators? So this is on the right-hand side, 5/8 plus 1/2. Well, I can't add these fractions because they have different denominators, but I can make them have the same denominator by multiplying that fraction 1/2 by the fraction 4/4. And there's other ways to do this. You can do least common multiple, but the main thing is you need to get the same denominator. And I know for this, a common denominator is 8. In fact, it's the greatest common denominator. So that's why I'm using that. I could also use 16, but that's a whole different lesson that I'll have to record and upload. Back to this. So now I have n is less than or equal to 5/8 plus, I multiply the 1/2 by the 4/4. So I'll have the same denominator. Well, my numerator first, 1 times 4 is 4, and then 2 times 4 is 8. Now, two fractions, same denominator, I can add my fractions. So I end up with n is less than or equal to 9/8. Excuse me. Now, if I convert that 9/8 to a mixed number, I'm going to get 1 1/8. Now, let's graph this. Let's see. I hope you all, yes, you can see. All right. Well, 1 1/8 is somewhere between 1 and 2. So on my number line, I'll start with -1, 0, 1, 2, 3. So 1 1/8. Well, here's 1. And 1 1/8, I'm going to just say is right here. 1 1/8. This inequality tells me that I need all the values for n that are less than or equal to 1 1/8. Since I have this part of my symbol that has the equal to, I know I'm going to use a square bracket at the point 1 1/8. So I draw my square bracket. Here's my square bracket. Now I need all the values. Now I need all the values that are less than 1 1/8. Well, it's everything to the left. So I draw my arrow to the left. Okay, last thing is interval notation. So what I'm going to write is 1 1/8. Well, I could have wrote 9/8, but I'm just choosing 1 1/8. Okay, comma, negative infinity. Since we had the square bracket up here to include the point 1 1/8, I'm going to have a square bracket down here. And then for the infinity sign, or negative infinity, we'll have just the left parenthesis. Okay. Those are examples for addition, and then subtraction using fractions. Next up is multiplication. So in this case, I have the inequality 7y is less than 42. And we want to solve this thing for y. Well, since this is multiplication, 7 times y, to get y by itself, we're going to divide both sides by 7. And now when I do that, I can cancel out the 7s on the left-hand side, which leaves me just y is less than, and 42 divided by 7 is 6. So now we have the inequality, y is less than 6. Now we want to draw a number line to represent this. So here's a number line. I'm starting at 2, 3, 4, 5, 6. We want to identify, okay, we got a number line. Back up for a second. We want to start at the point 6. But notice that we have just less than. So at 6, we're going to use a parenthesis because we do not want to include the number 6. And then all the values of y that will make this inequality true are to the left. That means 5 will be less than 6, 4 less than 6, 3, 2, 1, 0, -1, -2, -3. You get the idea. Okay. Draw a line to represent that. Now, for interval notation, here's our 6, comma, we're going to negative infinity. We're going to use a bracket, not a bracket, using a parenthesis. Parentheses because we have less than. And then for negative infinity, less than. Okay. Our next example will actually involve a negative number. And here's the thing about when you have a negative number, when you have to divide by a negative number when solving for a variable, it's going to change the direction of your symbol, but you'll see. I've got the inequality -10 times A is greater than or equal to 50. First, we start by solving this thing for A, and we do that by multiplying both sides, multiplying. You're going to divide both sides by -10. On the left-hand side, -10 cancels out with -10, leaving me just A. Now, because we divided by a negative number, it's going to change the sign from greater than or equal to less than or equal to. Now, why is that? I don't know. That's just the math rule that I know that works. Probably, no, not probably. Somebody had a theorem way back in the days that proved this thing. You don't want to hear this stuff now. You just want to know how to do it, right? Yeah, right. Okay. Just trust me. You divide by negative, you change the sign in the opposite direction. That means our greater than or equal to will become less than or equal to. And then 50 divided by -10 will give us -5. So now I have the inequality. A is less than or equal to -5. Now we got to graph this thing. So we want all the values of A that are less than or equal to -5. Okay, on my number line, here's -5. Now, since is less than or equal to, I need to use my bracket at x equals -5 is where I place my bracket. And all the values less than is going to be everything to the left. Now, in interval notation, it's going to be this. -5 to -infinity. Since I had my square bracket up here, have a square bracket down here. Square bracket. And then for -infinity, it's going to be parenthesis. And one more example. This one involves a fraction. So we have the inequality, -20 is less than 4/5 u. So to get u by itself, we want to multiply both sides of that symbol. Multiply both sides of that by the reciprocal of 4/5, which is 5/4. And I'm going to write this in brackets. So you can see that we multiplied both sides by 5/4. So when I do that, for the right side of my inequality, 5/4 plus 4/5 is just 1, because a number times its reciprocal is 1. And it'd be 1 times u, which is just u. And for the left-hand side, I have 5 times -20. That gives me -100 for my numerator. And for my denominator, I get 4 times 1, which equals 4. Now, -100 divided by 4 is -25. And that's less than u. I can also write the same inequality this way, because reading from left to right, this is -25 is less than u. If I read it from right to left, it's u is greater than -25. It doesn't change anything. It's just flipping it around. So what I wrote here was -25 is less than u, or, and that's reading from left to right, from right to left, it's u is greater than -25. And now let's graph this and then write the interval notation. Oops, that was positive. It should be negative. So on my number line, on my number line up here, yeah, -25, writing it in bigger intervals. -25, -20, -10, 0, and then 10. Since I need u greater than -25, I know that at the point u equals -25, I'm going to have a left parenthesis, -25, comma, infinity, and then a right parenthesis. And so that concludes my lesson on solving linear equations. If you have any questions, hope you can rewind back to the point where you had questions, look at the explanation again, write it down, take your time, make sure it makes sense. All right, y'all, take care. See you next video.